Welcome to the Windshield Chronicles, a mental sequence of operation.
This episode brought to you by Dennis Soukup and Sunrise Refrigeration. Learn more about Sunrise Refrigeration at sunriseref.com.
Well, thank you all for joining us once again. We're hanging out with Dennis Soukup. Dennis, thanks for joining us.
Glad to be here today, Clifton.
Now, a lot of people know Dennis from the HVAC excellence side of the business, but they don't know him from the contractor side of the business. So, Dennis, tell us a little bit about your history in the business.
Well, okay, my history in the business goes back to when my time in the Air Force was ending and I realized I couldn't continue to do what I did in the Air Force because the war was ending, and I was able to have the Air Force send me to a night school as an adult in uniform, and I selected then an air conditioning program in Las Vegas that was at that time being taught through the college, but being taught at a local high school. And from that, I actually left there with basic skills of an air conditioning technician. And as an air conditioning technician, worked for a couple of companies. By 1981, I took the contractor's test, got my license, opened up my company as a carrier dealer, if you will, because that's what I was doing the most with. And a lot of people ask me, well, how did you get so much into commercial refrigeration and ice machines? And my answer was I lied. You know, I was working on a rooftop at a Carl's Jr. And I came down the ladder after fixing the air conditioner, and the manager was in a panic going into lunch and said, "Can you fix my milkshake machine?" And I just said, "Yeah, of course."
Hey, well, sure, so why not? I'm here.
I took the book off their shelf in their office. I went out to my truck and hurried up and sped through a few pages, and I got lucky. Nice. I fixed that milkshake machine, and the next thing you know, they wanted me to be their service company for, at that time, there were only 4 stores in Las Vegas. Now there are 28. Wow. And that led into a long history of becoming an ice machine distributor and a walk-in box company in Las Vegas, which my company still does today. And as a matter of fact, I too was in a training yesterday morning on a brand new type of ice machine that is coming out. So my entire company was in school yesterday morning for about 4 hours.
Oh, man, I love it. So you've been around and seen many changes in ice machines. Well, let's talk about a sequence of operation of an ice machine. So we're in our van, we're heading out to a job. All we know is that we have a call for an ice machine. Dispatch has no more information than that. So let's mentally prepare ourselves before we get to this job.
And that takes me back a lot of years, because it makes me think of when the first time I took the cover off an ice machine. I had no idea what I was going to see or what to expect. Right. So, yes. So now there, I don't know, probably a good 7 major manufacturers of ice machines out there today.
I'd say so.
And there's some slight variances between how they do things, but the basic sequence of operation is going to be identical in all. So if I were to start with that, the first thing I'm going to say is, we're going to have to take on some water.
Right.
Now, some machines are going to use a float, which is a lot like a swamp cooler or a toilet, if you will.
Sure, mechanical device.
Water trickle in until the float says we're full. Some machines are going to use electronic probes. Probes being that when the water comes in touch with them, it sends a signal through the water, and there's an electronic board that will be involved in that machine that says, I now have a batch of water. And from that batch of water, I'm going to make a batch of ice. So there, the first step has been set up. Now the machine will turn on, and it doesn't know sometimes how long it's been off. So that water that could be laying in there could be contaminated.
Right. Who knows what's in it?
In there a while. Yeah. So a lot of machines will actually dump. We call dump that or purge that. Pre-purge. Let that water go down the drain. So we start with a brand new fresh fill cycle again. So now we know we've hopefully taking on fresh and filtered water, because there must be a filter hopefully attached to that machine. Now we begin the startup process. So as the machine starts up, once the fill process is going, today's modern machines are very clever. We'll actually start with opening the hot gas valve. Nothing's going on right now, but by opening the hot gas valve, I've relieved the pressures on both sides of the machine. The high side is now dumped over, and the high and low sides become equal. Well, the neat part about that is it makes the compressor start without a big load already on it. Absolutely. So the start becomes soft. I
much
call
softer
that
start, lower heat draw.
And then again for 5 seconds, that compressor will come on and that valve will still remain open, letting that compressor get up to RPM before it switches and starts the freeze process. I want to explain that because a lot of technicians miss that. They think there's something wrong right away.
Right.
So after that
Sounds
valve
a little
closes,
different on startup.
it does. It does. It makes a big difference. So now when that valve finally does close, and it's only a matter of seconds, we begin the actual freeze process. My evaporator plate is going to start getting very cold. My condenser is going to start getting very warm. So the one thing we know about water is we freeze the purest of water at 32 degrees. So this is now a cascade principle. We have a sump. We have that batch of water we talked about. I got a water pump that's picking it up. And if you will, it's running over a dam. And that's cascading down in and out through all the cells that make the ice. And think about if we're freezing the purest of the water at 32 degrees, then all the garbage in the water, I like to say the blood, guts, and rocks,
all of our impurities, minerals,
it's falling to the sump.
Sure.
It's in the sump, and it's now allowed to be in greater concentration because that's all the filter does for us. We can't filter out scale. We can play with it.
Right.
We can change its molecular structure, keep it happier in a greater concentration. So now that as I'm freezing that purest of ice, I have those concentrated minerals ready to go down the drain and start the process again. Well, all right, so that's what's happening. The purest of the water is freezing in and out of these cells. The garbage of the water is continuing to fall to the bottom, and I'm finishing filling in the cells. Here's where we need the next device, something that has to tell us that ice is now present on the plate and is ready to be harvested. We like to see that the cells are filled in. There could be a dimple there. That's normal, but we want a bridge thickness of about 1/8 of an inch.
In between each individual cell.
Right. It's a webbing, if you will, connecting the cells together. And that's only there so that when we harvest the ice, we can harvest it in a full sheet. It should be 1/8 of an inch because 1/8 is just enough to keep it together, but enough so you don't need a hammer to break it apart.
Absolutely.
It should fall apart easily when it hits. An ice scoop with a bartender should be able to break it up and use that ice without a great difficulty. And when people start to adjust and play with that thickness, well, then there's a lot of problems that occur with the machine and you start to lose production. So as we built that ice, we now have we could have an ice thickness probe, a temperature pressure control, or simply a sonar control that senses that the ice is there, it's present, it's thick enough, it's ready to be harvested. So boom, now we switch again, either a board or a relay, and we're going to ask it to go into hot gas, kind of like a heat pump. We're going to reverse the cycle, start pumping the hot gas into the evaporator plate. While that's going on, don't forget about that concentrated water. We're sending that down the drain. That's going down the drain now, and we're flushing getting ready to bring on some fresh water. So the plate's getting warm, garbage water's going out, and then pretty soon that capillary action on the back of that ice will let go, and it's going to fall into the bin. Now, when it falls into the bin, older machines will have a mechanical thermostat. If the ice lays on that stat and gets cold, it's going to shut it off. Newer machines will have just a damper that'll have incorporated a magnetic switch. So when the ice hits the damper, one, it's set up the stage for another cycle. Or if the damper should stay open, then it's going to say, I must be a full bin, and I'll turn it off.
Right.
Okay. So let's just assume that the bin is not full and we finally have harvested the ice. We'll go ahead and that damper will go down, setting up the cycle. It'll come right back up and go back into the freeze cycle. Now, in that case, we don't have to do that beginning part where we did the soft start and we pre-chilled the evaporator. And that's another important step that a lot of machines are doing today. We're pre-chilling the evaporator, and that's what we call to prevent from slushing. Slushing ice can be damaging to the pump and so forth. But anyway, once we do that and that damper resets, we're ready to start with the freeze cycle again and then move all the way forward to a harvest. But if the damper should stay open, let's say for a number of minutes, 30 minutes or whatever, it's telling us that ice is laying there. It can't fall in the bin because the bin is full, and it's waiting for someone to scoop that ice, knock it loose, and then the damper will start, and we'll go back to that first step. The first step where we purge the water, bring on the fresh water, soft start, and then recycle again through the cascading principle, bringing the ice back to the plate to another harvest.
Fantastic. Complete cycle.
Complete cycle. One of the things that's, and some of the things that's kind of unique, and I see as test questions all the time is, people will say, what temperature is the evaporator when ice is formed? And they right away want to say 32 degrees.
Right.
Well, no, that's not
Gotta
true.
Be colder than 32.
It has to be colder. We got to have that saturated suction temperature. And actually, it's unique. It started back in the old days of R12s when I used to log it in at 18 degrees Fahrenheit. Mm-hmm. That was precisely the point when 32 degree water became 32 degree ice, or the latent heat of fusion took place. So your evaporator was at 18, and if you looked at your charts of R12, there was your saturated temperature where 32 degree water became 32 degrees ice. And as we've migrated these years now into R290, those principles are coming back. That R290 is a lot like the performance of R12. For a while there, those pressures went way up in
Absolutely.
The years of 404.
Especially 404, yeah.
Right. Now they're coming back down again to the R290s, is bringing it back down to where at 18 degrees, we see that latent heat of fusion. And if you're servicing an ice machine, it's fun to watch that exactly when it happens, because everything will be circulating and cascading like I talked about. And then suddenly you can see that slush appear into your water sump. Some machines will do different things to combat that. They'll let maybe 6 minutes into the freeze cycle, they'll pause and pulse that incoming water valve and shoot some incoming tap water or warm water to counteract that slushing. Some machines have dampers or diverters in the trough to catch the slush before it gets to the pump, so the pump doesn't cavitate and pick up that slush. And then, of course, now most machines will pre-chill. Pre-chill meaning once we soft started that compressor, we'll let the evaporator freeze down a little bit with no pump running, no water, get it nice and cold, and then bring the water down and start that cascading principle. And it really is unique to watch that, to see it freeze the best of the water. That's what you have to think about. I'm freezing the best of that batch of water to the plate and letting the garbage cascade out. Those minerals and those deposits freeze at colder temperatures than 32. That's why we're able to almost purify the water during that cascading principle. So having an incoming filter is a good thing. It allows you to stay in solution, and it's not going to prevent you from having to clean the machine, exactly, but it's going to help you. It won't stick to the sides and the parts as hard as it does without a filter.
What about a general sequence of operation for cleaning a machine while we're talking about those heavy minerals?
So a good cleaning process, the older machines, there was absolutely not a mechanical type process. The new machines today are pretty simple. They got reminders in them. They're going to tell the owner and tell the technician, hey, I'm due for a cleaning. And they're pretty much a plug and play. You can actually push the button and say, do you want to clean and sanitize? Yes. And then it's going to tell you, okay, now you add your chemical, and basically you stand back and the machine will circulate. It'll flush, clean, and then it'll tell you it's time to add sanitizer. Now, let's go beyond that. And this is a kind of a frustrating part for me when some people think you just pour a bottle of chemicals in it and you're done.
Right.
That's not the case at all. So first off, in effectively cleaning an ice machine, and here in Las Vegas, we have some pretty tough water.
Sure.
And people say, is it hard water in Las Vegas? Well, take a look at the Grand Canyon. Tell me what you think. We cut it. That's a lot of water. That's hard water. Okay, so I like to start off with, you take a lot of the removable parts. Take that splash curtain off. Take that damper out. Take the water sump tray out. Get all that stuff to a 3-compartment sink if you can, and get it soaking in some solution to help you thoroughly get all of it. Then's the time I reassemble all of that and add some chemicals so that it can cascade over the evaporator plate. And you're going to need a brush. You need a little bit of a brush to make sure you're breaking that calcium deposits up and you're getting all of that off of there. But there's one important thing that people don't know about ice machine cleaners. There's a couple of grades. Mm-hmm. I recommend check the manufacturer, because those plates are coated with certain materials. And if you can use the wrong ice machine cleaner, you'll damage the evaporator plate.
Absolutely.
But you're not done there. You're not done there, because there is the problem of what we call pink slime or bacteria slime. All the ice machine cleaner in the world will not touch the slime and
kill
bacteria.
algae.
You're not done until you've sanitized that machine. Sanitizer is a separate little bottle, a separate chemical. You put it in, let that circulate through the system, inside and outside all of your tubes, through your cascading system, down the evaporator, and now you're sanitizing and killing bacteria. Very important in places that bake bread, throw beer cans down the drain, because as soon as that yeast goes airborne, it's looking for the coldest, wettest place to live.
Right.
And where's that? In your ice machine. And the minute the health department comes in, they're going to lift the lid, they're going to slide a mirror underneath that water tray, and they're going to see stalactites of slime. And where's that slime dripping and falling? On top of the ice. On top of the ice. Now, again, you're not done, because a lot of guys used to do this. Clean an ice machine with a bin full of ice. I'm sorry, but all that urine not going to contain that chemical.
Absolutely.
You have to do what we call in the trade, burn that ice. You're going to have to get rid of it. Think about what you're doing with it before you start. I usually tell the bartenders, let's fill up your station, because you're going to be out of ice for a little while. Get that ice out of the bin, because if you haven't taken sanitizer and sloshed and mopped it all around the internal liner of the bin, you have not completed your job. You have not sanitized. That's food, and that's where the food is being stored. A lot of students used to ask me, well, Mr. Soukup, how do you know when the ice machine's actually clean? And my answer was, when I let my grandkids have a drink.
Very good point. Dennis Soukup, thank you so much for joining us today. We appreciate your time.
You bet. Anytime.